looking at joint variation for today. We have already looked at direct variation and inverse variation in our previous videos. I'll leave the links in the description below. Alright, so our question for today is: the force F of attraction between two bodies varies directly as the product of their masses, capital M and then small m, and inversely as the square of the distance d between them. Given that the force is 20 newtons when the bigger mass is 25 kg, the smaller mass is 10 kg, and the distance is 5 meters. Find A, an expression for F, which is the force in terms of the bigger mass, the smaller mass, and then our distance. Then B, the distance d when the force is 30 newtons, the mass, which is the bigger one, is 7.5 kg, and then the smaller mass is 4 kg. All right, so let's begin with our expression. So the force F varies directly as the product of these two masses, which is a bigger m and a smaller one, and inversely as the square of the distance d. So inversely, which is divided by d squared. All right, so the next thing that we need to do is to change the variation sign into an equal sign. By doing so, that will become F being equal to, we have to introduce our constant of proportionality, which is K. So this will become K m multiplied by a smaller m over d squared. All right, so with this, we have been given all the values of these variables for us to be able to find our constant of proportionality. So what we are being given in the question is that our F is equal to 20 newtons. Our bigger mass is 25 kg. Our smaller mass is 10 kg. And our d, which is the distance, is 5 meters. So what we need to do is to substitute these digits into our equation. So this will become 20 equals K, which is unknown, multiplied by 25, which is also multiplying 10 all over 5 squared. Okay, so this will become 20 equals, this is going to be K 25 10 over 5 squared is 25. So we can boldly say that this 25 will cancel this 25. So what we would have left would be 20 equals 10k. All right, what we need to do is to divide this side by 10, divide here by 10. Finally, our value of k would become 2. All right, so if we have the value of k, then we can replace our constant of proportionality here, which is our k, by 2. So let's do that. So this will then become F equals 2 capital M small m over d squared. Okay, so our first question, which is our A, is saying that we should find an expression for F in terms of M small m, and then d. So this is the expression. So we have answered the first question. Now let's move on to B. The B is saying that we should find the distance, which is our D here, when our F is 30 newtons, our M being 7.5 kg, and our smaller m, which is the mass, is 4 kg. So our distance is unknown. So that's what we need to find. So let's do that. So this will then become, our F is 30 newtons. So this is going to be 30 equals 2 multiplying, our M is 7.5, which is also multiplying our smaller mass, which is 4. This is over d squared. We don't know that, so we need to find that. So we can proceed by saying that this is then going to be 30 equals 2 times 7.5 is 15. 15 times 4 is 60. So this will become 60 over d squared. This 30 is over 1. So d squared times 30 would become 30 d squared equals 60 times 1 is 60. So the next thing that we need to do is to divide through by 30. Divide this side by 30. So finally we can say that this would go with this. When 30 cancels off 1, it will go into 62 times. So our d squared is 2. We are interested in d, which is the distance, not distance squared. So we need to pick a square root on both sides. When we do that, this will become d equals square root of 2. And finally, d would become 1.414 meters as our final answer. I hope this helps.